Okay. So one important development is the rise of proof assistants. We have wonderful AI-assisted um, softwares, Coq and Lean, that express proof in formal language that can be verified rigorously. In 2005, we got major breakthrough from machine learning system that designs to search for mathematical patterns. Even in 2019, DeepMind developed Alpha Tensor, and Alpha Tensor treats new matrix multiplication algorithm as a game that discovered new algorithm beating 50 years old records. In 2021, even Lean and MATLAB, these verified formally verified thousands of theorems. So mathematicians collaborate with machine at a larger scale from 2021. Even in 2022, AI system began solving competition, mathematics competition, and even at human levels. Like they were not just giving the abstract; they were giving rigorous and comprehensive type of solutions of such mathematical exams even by using large language models and reinforcement learning. And in from 2024, Alpha Proof and Alpha Geometry solve international mathematics Olympiad problems, even at silver medal level. So now there arises an important question: if AI can perform many mathematical tasks, does it actually understand mathematics? So this is a question to everyone asking nowadays to each of us. Now, in our part 3, I will explore what AI can and cannot do because AI has its limitations and some creativity gap. First, we see what AI can do, like until today, what are the advantages we are having from AI. First of all, it matches top human performance on geometry, international mathematics Olympiad, geometry and algebra 2020-24. Like it has solved as we human solve this, and this performance is comparable, as I told earlier, to a silver medalist level. Even I told earlier, Lean and Koch, they verify entire mathematical libraries, formalize modern mathematics theories like condensed mathematics developed by Peter Strauss. Then conjecture generation. AI analyzes large mathematical dataset and detects hidden patterns. This can help propose possible new mathematical conjectures for research to investigate. Symbolic computation, we can say it's a huge contribution in the field of mathematics, like Wolfram Alpha Mathematica. They solve integral equations and even differential system instantly. Earlier, this was not an easy task. Like for doing symbolic computation, we have to spend a lot of time. So we are grateful for AI in many discoveries and many proofs and system solvers. Then Alpha Tensor found new matrix multiplication, and also AI reads and synthesizes thousands of paper to identify open problem and connections. Previously when we are doing research, if we are having literature survey, we take a paper and then we spend about days, like weeks on it to understand. But now it become comparatively easy that you can take such type of help. You can get the idea of paper within no time. We have many research softwares available right now. But always when there are benefits, there are advantages, there are also pitfalls, there are also some limitations that AI cannot do. For example, in mathematics context, true conceptual understanding. AI lacks true conceptual understanding. Basically, AI manipulates symbols without grasping meaning. So it cannot feel confused, curious, or surprised. Like when, as a mathematician, you are solving some problem. Sometimes you get confused. Sometimes you are curious to know what will come ahead, and sometimes you are surprised. Oh, we have solved this. But this type of thing is not supported in AI. Then we have a limitation in genuine creative leaps. many of greatest breakthrough in mathematics required imaginative insights that could not be easily derived from existing patterns. For example, Riemann hypothesis and Fermat last theorem. So there should be some creativity, and AI is always dependent on humans for creativity element. Then we have cross-domain insight. Human often makes surprising connection between different areas of mathematics. For example, humans link number theory with geometry and physics, but this cross-domain insight is missing in AI. Then we have mathematical taste. Experienced researchers develop a sense of which problems are deep, which approaches are promising, and which proofs relevant, reveal genuine structure. So this mathematical taste cannot appear in AI calculations. Then we have embodied intuition. Geometric intuitions come from drawing, visualizing, and physically interacting with space, while AI lacks a body and cannot gain this kind of embodied spatial understanding. And then, most important, intrinsic motivation. AI does not stay up all night obsessing over a problem for the love of it, because we know mathematics is a passion, is understanding, is love. So if a machine lacks such type of motivations, so mathematical portion passion is always human element. So if we analyze creativity gap, AI can verify a proof is correct or not, but humans know which proof to seek. Similarly, AI can search known solution spaces, but human can imagine entirely new problem types. Even AI can recognize established patterns, but humans uniquely can invent new mathematical structures. AI can compute at superhuman speed, but human uniquely choose what is beautiful or deep. Like we don't need to do the junk stuff. We can only choose the thing that is relevant, that is requirement, and that is beautiful or deep in meaning. AI can suggest next steps in the proof, while human uniquely experience the moment. So whenever you are doing something and you get the solution, you say, we have solved it. So all type of emotions are missing in AI. AI can give you the solution, but in my opinion, human are always dominant on that. Now I come towards the fourth part of my presentation, the human element in mathematics. Ramajan once said, an equation for me has no meaning unless it represents a thought of God. Ramajan had little formal training, but he produced astonishing formulas and conjectures that later proved correct. His insight seemed to emerge from an extraordinary intuition for patterns. His intuition was a direct pipeline to mathematical truth. AI has no such pipeline. Even subconscious at work. Another mathematician, if you remember, Henry Poincaré, described how solution to problems sometime appeared suddenly after long periods of unconscious incubation. He would struggle with a problem for days. Then suddenly he experienced a flash insight while boarding in a bus or taking a walk. AI has no subconscious incubation. This phenomena suggests that mathematical creativity involves not only logical reasoning, but also subconscious cognitive processes. So, without this subconscious cognitive processes, we can do the routine work, but we cannot discover the new things. So, pure intention,